Transportation management systems are used to shorten the response time to incidents and to reduce the impact of incidents on traffic. We have developed a simulation-based learning environment to provide transportation students and operators with an appreciation of the impact of incidents on traffic delays. We used an application framework called SIMPLE for constructing simulation-based learning environments. SIMPLE has been used successfully for applications such as vacuum pump systems, silicon chip fabrication, or the hydrology of the Nile. Our interface consists of two main areas, the simulation itself and the guidance material. Students can read about traffic performance, find exercises, or explanations. Passing the cursor on blue terms highlights the corresponding item on the simulation. The simulation area shows a freeway paralleled by an arterial with a series of traffic signals. On the right, a chart will display the delays over time. On the left, a time-space diagram represents the timing of the traffic signals and the flow of traffic. For each signal, a timeline represents a succession of green, yellow, and reds. A tutorial explains how to change a split or relative duration of red and green, or change the offset between lights, or change the entire cycle time of a light. Short animations further explain the diagram. As a car goes down the arterial, its progress is also shown on the time-space diagram, traveling or stopping at the red light. Flows of cars are shown as bands on the diagram. Here, the first cars kept on going, while the later ones had to stop at the red light, creating a second band. The volume of the cars and the speed limit can be adjusted. The queues of cars can be seen here. Let's go back to the whole simulation. At the start, users can choose freeway volume, speed limit, and the number of lanes. The delay chart on the right shows no delay. Lanes can be closed on the freeway in order to simulate incidents. Delays now appear on the chart. After a while, the delays become severe and the queue gets longer. Users can reopen lanes and see the delay reducing, but let's close the lanes again. Users can also change the message on the variable message sign. Depending on the message, a different proportion of vehicles will exit the freeway and enter the arterial. The diverted traffic can be seen on the time-space diagram entering during a red phase. But of course, there is normal traffic on the arterial. If the sum of the bands exceeds an intersection capacity, vehicles will have to wait more than once, which is called a cycle failure. Users are then encouraged to try adjusting the offsets, splits, and possibly cycle times to increase the capacity and avoid failures. It's not easy with such heavy traffic. Users can also check the effect of their changes on the opposite northbound traffic. Ideally, one would hope to see that delays increase less rapidly or possibly stabilize. But the most efficient strategy remains to respond to the incident quickly, reopen lanes, and then watch the delays and the queues slowly decrease.